Now, in order to increase our power generation in the steam turbine, you have to compound the turbine. What is compounding? Compounding means you have to add number of stages in the turbine. One stage means you consist of one set of fixed blade and one set of moving blade. That means this is one stage, and this is another stage. That means 3 stages are required to increase the power output of the turbine. Therefore, all steam turbines are compounding, so that we will get more output. In this impulse turbine, the fixed blades they acts like nozzles, and moving blade, here the kinetic energy drops. Again, in the fixed blade the velocity increases, then the velocity decreases like this. So, here the total reduction takes place in different stages, so that we will get more output. So, if you draw the pressure and velocity distribution of this diagram, we will be very much clear. This is the boiler pressure, this is the pressure distribution, this is the pressure distribution in the turbine, inside the turbine, pressure distribution. And this is the velocity distribution. So, you know in the fixed blade velocity increases. Here this is the fixed blade where velocity increases. Then between the fixed blade and the moving blade there is some gap. In this gap the velocity also remain constant. Then in the moving blade the kinetic energy fall. So this is in the moving blade. Then here there is a space in between fixed blade and moving blade. Then in the fixed blade, in this part the velocity again increases. Then next blade, moving blade, it decreases like this. So it will last to your condenser velocity, where the velocity is very less, Vc, and C also your condenser pressure. So this here in different stages the pressure reduces in the turbine. This is called your pressure compounding. Pressure compounding. And this takes place in the turbine, it is called a reactive turbine. Another compound is your velocity compounding. Where pressure remains same, velocity reduces. Here I have taken two stages. Initial weight V0 in the fixed blade, this is the fixed blade and this is the moving blade. Again this is fixed blade, this is moving blade. So in the fixed blade already I have told that it acts like nozzle, so here the velocity increases. So V0 to V1. So in between two moving blades there is a gap. So here the blade enters the moving blade and doing some work, it will the velocity kinetic energy reduces. It will convert to mechanical energy here V1 to V2. Again this V2 in the fixed blade increases to V3. Here this V2 again increases to V3, enters the turbo blade, then it reduces to V4. So, that means here the velocity component, that means velocity reduction takes place in different stages, different blades. Here we have shown two stages. This is one pair, fixed blade and movable, it is called one stage, this one stage and this another stage. Two stages I have shown. So, in two stages, the velocity first increases in the fixed blades from V0 initial velocity to V1, and then it is doing some work in the moving blade, it reaches to V2. Again in the fixed blade it is increases to V3, then it reduces to V4. That means here there are two velocity triangles. You can, if you will draw the velocity triangle, it will be two velocity triangle. So, this is all about the theory part, mathematical part of the steam turbine. Now, we will discuss the advantages and disadvantages of steam turbine. Next is your advantages of steam turbine. You know, this is a steam turbine is a rotary machine, not your reciprocating like your steam engine. You know, steam engine and steam turbine both works in the same Rankine cycle. Steam engine and steam turbine, they both are steam prime movers, but difference is that the steam engine having piston cylinder like your diesel engine, petrol engine, but in the steam turbine there is no any moving parts. That means here there is no less friction because there is no sliding motion, it is only rotary type, the blades rotates. But in case of steam engine, the piston glides over in the inside the cylinder. So, there is very loss in power, and there is some limitation in steam engine, but those limitations you will not find in the steam turbine. If we will write one by one the advantages, number one advantage is the thermal efficiency of the turbine is much higher than that of steam engine. The thermal efficiency means output by input of the steam turbine is much more than, very high than your thermal efficiency of steam engine. This is first advantage. Efficiency will be more of the steam turbine, having same pressure limits of boiler and condenser pressure. The steam turbine has more thermal efficiency. Number two, the power generation in a steam turbine is at a uniform rate. Therefore, there is no need of any flywheel. You know, this is a rotodynamic machine. So, here the power generation is having no any non-uniform. That means the power generation is always constant, uniform. Therefore, there is no any zero power anywhere. Always constant power is the output of the turbine. So, therefore, there is no need of flywheel. Flywheel is not necessary. You know, flywheel function is to store mechanical energy and it dissipates at the time of need. So, here in this steam turbine there is no need of any flywheel. Number three advantage is the higher speed and greater range of speed is possible in case of turbine. More than limit is your 3000 rpm. In any steam turbine, any steam power plant, the turbine rotations is always limited to 3000 as per the frequency of the generation in our India is 50 hertz. So, this limits that the turbine should not rotate more than 3000 rpm. But in case of steam engine, the rpm is very less, about 1000 maximum. But here the steam turbine rpm is very high. It may be very more than 3000, but we have to limit the steam turbine by governing action mechanism to this limit. So, that means your speed limit of the steam turbine is very high. Speed range of the speed is very high. Number 4, this is the advantage. Number 4 advantage is or merit. In a large thermal power station, where we need higher output, the steam turbines proves very suitable, as these can be made in big sizes. Se kouchi any super thermal power plant, anywhere, this steam turbine can be only able to produce high output, because it can be designed in very big sizes compared to your steam engines or gas turbine. Any turbine, steam turbine can be designed to a big size, and in different compounding you will get the more output in the steam turbine. So, it is possible to design big size turbine can be possible in case of steam turbine. Number 5, the merits number 5 is, with the absence of a reciprocating pass, the balancing problem is minimized. So, you know the construction of the steam turbine, that there is no any reciprocating parts. Reciprocating means your cylinder piston action is your reciprocating. This is reciprocating action, to and fro, and a push rod, a piston rod, then a crank, connected rod, then crank. This is the in case of steam engine, but this piston cylinder is not there. Only blades are there. Blades are which are having, they are rotating. So, therefore, there is no lubrication. Sorry, no balancing. Balancing is not a criteria here. Balancing is nil. Balancing nil for steam turbine. So, there is no need of any balancing, because in reciprocating engine, so the imbalance balancing force is not always developed, is to be balanced, the crankshaft, but here there is no crankshaft. So, there is no need of any balancing. Number 6, no lubrication is required, no internal lubrication is required, as there are no rubbing parts. So, there is no rubbing parts. एटा हमर जो एटा हमर friction एटा आ भीतर जो motion rubbing होची, it is not there in case of turbine. So, there is no internal lubrication of the turbine blades or any its moving parts, rotor. Number 7, there is no loss due to initial condensation of steam. So, there is no loss. The initial condensation of steam does not take place. Therefore, there is no loss. Number 8, it can utilize high vacuum very advantageously. Vacuum, very low pressure can be there for in condenser. Number 9, last is, considerable overloads can be carried out at the cost of slight reduction in overall efficiency. So, that means it can take any overload, it can meet the overload without any very small loss in efficiency. So, this is the advantages. Next is your disadvantages. Disadvantages of steam turbine. Number 1, relatively high overnight cost. Cost is very high. The installation of this turbine is very high cost. Number 2, steam turbines are less efficient at part load operation. Part load मान जिते तुम लोड टा कमिजिव से तार एफिशिएंसी ऑल्सो रिड्यूस. लो एफिशिएंसी इन पार्ट लोड. Part load माने when the load decreases part load. Number 3, they have longer startup than gas turbine. That means it will take more time to start than your gas turbine. Gas turbine टा जल्दी start होगा, steam turbine takes long time. Number 4, less responsive to changes in power demand. Less responsive to change in power demand compared with other turbines. The power demand पाई जिते आमर power बढ़े कमे, it is less responsive. Response टा कम than other gas turbines like this. So this is about your advantages and disadvantages in case of steam turbine. Now next is I will use list of 10 thermal power stations in Orissa. It is in your syllabus. List of 10 thermal power stations in Orissa, in our state, in state, with their capacities. First is NTPC Konya, NTPC super thermal power station, super thermal power station. Because it is super thermal, because the power output is more than 500 megawatt power station. Here the capacity is 3000 megawatt. That is, it has 6 unit of each 500 megawatt. माने गोटे यूनिट रे तमर 500 मेगावाट प्रोड्यूस होतो गोटे टर्बाइन रे, सेमिति तमर 6टा टर्बाइन थिबो, 6टा टर्बाइन यूनिट थिबो. टोटल तारले तमर हे गला 6 multiplied by 500 is 3000. That total capacity of NTPC Konya in Angul district. This is your central government organization, and the private, in the private Vedanta Limited, they are producing second 2400 megawatt. Number 3, Jindal, JITPL, Jindal Power Limited, in Derang, they are producing 1200 megawatt. Number 4 is Nalco CPP, captive power plant. CPP full form is captive power plant. Nalco has their own power station. They are in the Angul. They are producing same 1200 megawatt. Number 5 is the JSPL in Angul. They are producing 810 megawatt. Then Aditya Power Limited, they are producing 750 megawatt. Aditya Power plant. Then Hindalco in Sambalpur, Hindalco, in Sambalpur, he is producing 467.5 megawatt and 460 megawatt. Then our state government OPGC, they are producing in the Jharsuguda, district, they are producing 420 megawatt. Another two in the Kamalang, and they are producing, one is producing 105 megawatt, and another is producing 460 megawatt in Kamalang area in the state. So, this is the 10 thermal power station producing in our state. Okay, in this way, I will conclude my lecture for this session. So, now we will stop, we will meet again in the afternoon. Thank you.